All right, so today, time to go back to our basics of graphing sine and cosine. I'm going to go through this quickly because we did it the other day. But if you consider the unit circle, there we have the coordinates of 1, 0, 0, 1, negative 1, 0, and 0, negative 1. What do you remember about the graph of sine of x? It's a wave. Starts at 0, goes up and down. It takes 2 pi before it repeats itself. Why 2 pi? 2 pi is once around the circle. Why do I divide into 4 parts? 4 quadrants. So you tell me, why does sine start at 0? Yeah, so this connection, I'm trying to help you make it. Hopefully it happens for you. The sine graph is simply just the y values of the unit circle. So we start off with 0, so it starts at 0. At pi over 2 or 90, it's at 1, so I go up to 1. When I get over to pi, I'm at 0 again. When I get to 3 pi over 2, I'm at negative 1. So it's simply the unit circle put to a graph. That's all it is. It's the unit circle unraveled, the circle of life. Almost made Maya laugh there. No, now she's laughing. Good, thank you. Appreciate that. So how is cosine different? Why? Because it's the x value, so it starts at 1. Yeah, cosine is the x value, so it starts at 1, it goes 0, negative 1, so on and so forth. So cosine starts up here at 1. Where does it go after that? Down to 0, goes through its cycle. Now what's interesting is this sine and cosine graph, they do look similar, don't they? In fact, if I grab this cosine graph and I put it up there, you can see how similar they look. In fact, they are the same graph. They're just shifted horizontally. Right? And that's a relationship that exists between those. So the sine graph has a maximum value of 1, a minimum value of negative 1, an amplitude of 1. We say that the amplitude is the distance from the center of the wave to the top of the wave, or from the center of the wave to the bottom of the wave. That's the amplitude. The period is how often it takes to repeat itself. That is 2 pi. It's the same exact values for cosine. Those are the parent functions. We will perform transformations on them. In chapter 2.5 from first semester, we did transformations. And I put this up in front of the board for you, and you freaked out when you saw it. But on Monday, you're going to have to graph this. Y is equal to negative 3 sine of 2x minus pi over 4 plus 1. Looks pretty bulky, right? Challenging. we're going to make it easy, folks. It's going to be easy because you already have a strong foundation for graphing that. We're not ready to graph that yet. What we're going to do is simply look at what happens if you put a number in front of it and what happens if you put a number in front of x. Well, first of all, that's going to change the amplitude. The amplitude is the absolute value of a. So we've already written this down once, but we took a day off to test, so this is just review from that. Does anybody remember how we determined the period? Formula. 2 pi over b, says Kayla. What will we do without Kayla? Apparently, if we're Brooke Meyer, we just don't show up. So shout out to Brooke. We hope you're doing well. And then, so how do we go about graphing these? Well, number one, mark off the amplitude. Great, I mark off the amplitude. Second thing, we mark off the period. And then once you mark off the amplitude and the period, the difference between sine and cosine, we can really figure out by identifying where it starts. Starting point. Sine starts at, and it trends up. If it was negative, would it still start at 0? Yes, but it would head down. Cosine does not start at 0. Cosine starts at the max or at the minimum. If it's positive, it starts at the maximum. If it's negative, it starts at the minimum. We good? Any questions? Going once, twice, 3 times. Flip forward 2 pages, not 1. Flip to this. We are going to sketch 4 graphs here. We have the time. We need you to keep pace. We start with this one right here. I identify the amplitude and the period. What is the amplitude? 1. What is the period? 2 pi divided by 1, which is 2 pi. So I mark off the amplitude, up 1, down 1. I mark off the period, 2 pi, pi, pi over 2, 3 pi over 2, negative 2 pi, negative pi, negative pi over 2, negative 3 pi over 2. Where do I start? Do I start by going up or by going down? Why? Because it's negative. It creates a vertical reflection. Look at your graphs to see how neat or disgusting they are. See who has good handwriting, who has atrocious handwriting. Okay, let's try this one right here. What's the amplitude? 4. What's the period? Why 2? 2 pi divided by pi. The pi's cancel. I end up with 2. So the period does not have to have pi in it. Okay, that can cancel. Mark off 4. Mark off negative 4. Mark off 2. Mark off -2. Smart board stops working because it's too stupid to be able to handle trigonometry. There we go. 1, -1, -1/2, -3/2. Where do I start? Do I head up or down? Head up. Does that look similar to our first graph? Yeah, it's quite misleading because number 1, 2 pi is much bigger than 2, isn't it? And also, this one has an amplitude of 4, which this is 1. So if we were to actually put these on the same graph, it might look more like, that one might be the one up here. Actually, it'd be even smaller. But if we were to put them on the same graph, they'd look a lot different, wouldn't they? And so we're going to give you that chance for this one down here. But before we do that one, we're going to do the y equals 2 cosine of x over 3. What's the amplitude here? And what is the period? I take 2 pi, and what do I divide it by? What do I divide it by? I divide it by 1/3. You divide it by whatever you were multiplying x by. X is being multiplied by 1/3. Why? Because x over 3 is the same as 1/3 x. So multiplying by 1/3. And so if I divide it by 1/3, 2 pi divided by 1/3 is 6 pi, because you multiply by the reciprocal. We get 6 pi. Very good. Mark off 2 and -2. 6 pi, -6 pi. If I take 6 pi and divide it by 2, I get 3 pi. If I take 3 pi divided by 2, I get 3 pi over 2. Anybody know what my third tick mark would be? Yeah. How do you get 9 pi over 2? You just, yeah. So Henrik is counting. He's like 3 pi over 2, 6 pi over 2, 9 pi over 2. Or you just take this first one, you multiply it by 3. You get 9 pi over 2. So where do I start here? I start at 2. I start at -2. See, it wants to start up at 2, but the negative creates a vertical flip, so it starts down at -2. Everybody okay? Okay, we try the last one together. We are not going to do this one, but we are going to do this one. Okay. I like this one because this really tests how well we understand this process today. Y is equal to -2 sine of x, and y is equal to 6 sine of 4x. What is the amplitude of the first one? And the bottom one is 6. So if I'm going to put these on the same graph, should I mark 6 or 2 for my my axis here? Yeah, because I want to be able to see everything, right? So 6 and -6. And then notice I'm just going to divide it into thirds. That way I'll be able to see the 2 and the -2, right? Again, the graphs don't have to be exact, but we want a general understanding. So we understand that one is only going to go up and down to +2 and -2, whereas the other one's going to bounce back and forth between +6 and -6. Now let's think about the period. What's the period for the first one? 2 pi. What's the period for the second one? Half pi, or pi over 2. Now, before I mark anything out, I want you to think about what that actually means, okay? This is where real understanding starts to develop. The bottom graph goes 3 times as high as the top graph, correct? And the bottom graph, it repeats itself at pi over 2, or 90 degrees, right? Whereas the other one repeats itself after a full circle, right? For 360 degrees. So this one repeats itself 4 times as often. So we're going to have 4 of these graphs for every one of those graphs. So it really gives you an appreciation for what's happening. Notice, because there's 4 of the pi over 2's within 2 pi, right? Well, look, 4 times as often as that. So let's mark this out. Pi over 2 is smaller, 2 pi is bigger, so I'm going to mark it all the way out to 2 pi. Multiple ways of pursuing this. I think that one of the easier ways of doing this is to take the one that stretches the entire period and graph that one first. So let's graph this top guy first, and I'll do that one in blue, okay? So where's it going to start? 0. And is it going to go up or down? Down to what? -2. See Jaden going for those colored pencils. We good with the first graph? Still got people drawing. I'm going to pause. Okay, the second graph, I got to go all the way up to 6, right? But notice I have to show a full cycle by the time I get to pi over 2. So that means within 1 tick mark, it's got to go up, down, and back up. So I'm not going to divide that in 4 parts. I'm just going to try to draw it to the best of my ability. It's not going to be perfect, but it'll be pretty good. I go up and down and back up, and I complete 1 full cycle in that set. Sometimes, believe it or not, students make fun of me. That's fine. I can make fun of you. We can go back and forth. But part of what they say is that my graphs are not very accurate. They're not very pretty. They just look like a big old mess. And I argue, no, I think my graphs are really accurate. And one nice thing is you can turn on your calculator. And if you go into y equals, you can type in those graphs, -2 sine of x and 6 sine of 4x. Do you think I should be working in radians or degrees? Definitely radians at this point. And if you look at your window, what is my x minimum? What is -6.28? That's -2 pi. And you can actually type it in like the scale. We should have tick mark every pi over 2. So I go, so I can actually type that in. Second pi divided by 2. And you can see that it converts it to the 1.57. So as I look at that graph, I want to be able to see a graph that is in fact, an accurate description of what I have right here. And you can see it. That's supposed to be the blue one. You tell me if I've done a good job or not. And that's supposed to be the red one. Do you think that's an accurate representation? Yeah, I think Alex wants to clap for me. Alex, you don't have to ask for permission. You just start clapping if you want to. Not you, Alex. That Alex wanted to clap, but so I thank you for that. So if you can do Monday's lesson, you can definitely set yourself up to get an A+ on the next test. Okay? Do not put off your homework. We will be testing quickly on this. Okay? We are going to have 4 basically days of a lesson, and then we'll be ready to get into the testing cycle. We probably won't be able to test next week Friday, but we will the following week. So stay on top of your stuff. And have a great weekend.